So this is your report for experiment 1. Remember to put your name, the date. In part 1, you're measuring the length of an index card, and metric units, you're determining that length in centimeters, and then your English units is the length of your index card in inches. In part 2, you're using your thermometer to determine the temperature for your boiling water and for the water that you have with ice. The theoretical values, you have them in the video for the procedure part, and then the experimental value are your actual measurements. Okay? You have two of them, one for the boiling water and then you have one for your ice water bath. And the correction factor is the one that you're going to be calculating. So your correction factor, and you have this also as part of your video for the procedure of the experiment. This is the theoretical value and this is your experimental value. So your correction factor will be your theoretical minus the experimental. To calculate that average, you're adding that plus this one divided by 2. So when you're doing this calculation for your average in the calculator, make sure that you're adding your correction factor for the ice plus the correction factor for the hot. Put those numbers in parentheses and then that divided by 2. That's going to give you the average right here. In part 3, you have your initial volume only for the burette because you're filling your burette all the way to the line of 0. Now the final volume for this one should be after you dispense the volume that you're transferring into the vial. So you're going from 0 all the way down to 25. So your final volume here in your burette should be 25. So the volume measured only for the burette is your final volume minus the initial volume. So final minus initial. The amount of water that you're measuring with the beaker and with the graduated cylinder is 25 milliliters. So if you check here, your final is 25, your initial is 0. So 25 minus 0 is going to give you 25. And you should have 25 for all of them because that's the volume that you're trying to measure. If you measure an amount of water that is different from 25, you should write down how much water you're actually using. So I'm going to explain this one down here and make sure that you include all examples for your calculations in your lab report. The theoretical mass, you're going to calculate that using the density. So I'm writing down here the density for water at room temperature, and this is H2O, it's 1 gram per milliliter. So every gram of water has a volume equal to 1 milliliter, 1 gram per milliliter. Okay. So if your volume of water is 25 milliliters, if 1 gram of water is it's the same as 1 milliliter, from here, your density, "25 milliliters of water is the same as 25 grams of water." So the theoretical mass using the density If your volumes here are 25, all of them equal to 25 milliliters, all of the masses that you have right here should be 25 grams. Now the mass of the vial you record in this one, this is your experimental data, your measurements. The mass of the vial plus the water, that's also your experimental data. You're measuring the mass for your vial A with the 25 milliliters that you dispense from the burette. Then you have in vial 2, the vial 2 with the 25 milliliters of water that you're measuring using the beaker. And then you have in vial C, the mass of the water that you're measuring using the graduated cylinder. So all of this is experimental data, okay, or your measurements. Measure mass of water, this is the difference. Look, you have the mass of the vial with the water and the mass of the empty vial. So the mass of the water should be the difference between those two. So I'm going to put the mass of the vial with the water represented as a number 2, mass of the vial without water represented as number 1. So to get the mass of the water, you're going to do your number 2, whatever number you have here, minus whatever number you have here. So the vial with the water inside, that mass minus the mass of the empty vial should give you how much is the mass of the water that you have in that vial. And you should do the same thing for the second one and the third vial. This right here is your theoretical value. In theory, you're calculating the mass of water that you should have based on the density. So to calculate your percent error, you're using this number right here, okay? Your theoretical value of the mass of water, the theoretical, minus this measure here, it's your experimental. So you're using your theoretical minus the experimental. All of that is absolute value divided by, again, the theoretical. And that should be times 100. Let me write it better so you can see the actual equation. So percent error will be absolute value of your theoretical minus experimental divided by your theoretical, and that's times 100. So this number that you have here is the theoretical. This number that you have right here is the experimental, and then the theoretical, you're using the same number twice, times 100. So if you get a percent error that it's a negative number, it's the same number but with a positive sign because your equation has the absolute value. So that's your experimental right there. And you have to do the same thing for the second and the third one. You have a theoretical value here, an experimental here, so you can calculate the percent error. And then for the third one, the same. You have a theoretical value here, you have an experimental value here, and you can calculate the percent error for that third sample. For part 4, you're determining the density for your cube. Remember to copy the material that's on the box, the length in centimeters, the width in centimeters, the height in centimeters, and you're going to calculate the volume. The volume is the length times the width times the height. You're determining the mass of your object using the mass balance, and you have to show me here the calculations for the volume, calculations for the density. So for your density value, you have the mass in units of grams divided by the volume, and the volume you have in centimeters cubed. Okay? So you're going to calculate the density and you're going to write down the number right there. For your your object with an irregular shape, you have your initial volume in the plastic graduated cylinder, the final volume, which is the volume after you're adding the cylinder inside of the graduated cylinder containing the water. The volume of the object is the difference between these two. So your final volume minus your initial volume is going to tell you the volume of the object. You're going to determine the mass using the mass balance, so you should have that number, and you need to show me how to get the density. The mass of your object with an irregular shape divided by the volume. And now in this case, you're measuring the volume of a liquid. The volume of a liquid, you're getting that one from the difference of your volume of water in the graduated cylinder. The volume of the water in the graduated cylinder is given in units of milliliters. So the density that you're calculating right here for this part, it should have units of grams per milliliter. For your object with a regular shape, you should have units of grams per cubic centimeter.